On a Sunday morning, the De Las Llagas family can be seen doing everyday activities, chatting amongst themselves, talking about anything and everything.
Ooh, what's that?
Ate, what are you cooking?
Ooh, ate, what's that?
Just frying some eggs. Do you want some?
Sure, but why are the egg whites clear? They are supposed to be white, right?
Good question. That is because of something called protein denaturation.
Wow, what's that?
Well, imagine protein as a ball of yarn, twisted and bundled up together in many different ways. When we heat it up, like what I'm doing right now, the protein yarn ball turns loose and changes shape. That turns the clear and runny egg whites into something solid and actually white.
Wow, the egg is transforming. It's like magic. So we're turning breakfast into biology lesson now.
Yup, let's see what else is hiding in our breakfast through experimentation.
So ate, what's the plan?
So guys, let's begin.
Step 1. Crack the egg. Separate the white from the yolk. Sorry, yolk, you're not invited to this experiment. Using scissors, divide the 4 egg whites into 4 equal parts.
Step 3. We'll prepare 4 treatments. Control, alcohol, room temperature water, and hot water. But guys, this water isn't hot yet. Could you guys please heat it up?
Step 4. Place each egg white into the cup. Step 5. Mix gently and observe and record any changes to its color and consistency. That's protein denaturation. The heat changes the protein structure.
The alcohol one is cloudy too. That means alcohol also makes proteins change.
Exactly. Different treatments like heat and alcohol causes protein to unfold in different ways. And the control one? Still slimy and clear. That's our baseline. Hold on. We're going too fast. We should explain to the viewers at home what protein denaturation even is. Just like Juliana explained to Rashid earlier, we can imagine protein denaturation as a ball of yarn that unravels and changes due to specific conditions. But what happens at the molecular level? Adding denaturing agents like heat, acid, and force breaks the three-dimensional shape of the protein. For example, when adding heat to the protein, the kinetic energy increases, causing the protein to vibrate rapidly, eventually causing the molecular motion to break the bonds that keeps the protein folded back to its primary structure.
Well, we used 4 different treatments. However, only 2 of them showed visible changes: hot water and ethyl alcohol.
Ethyl alcohol disrupts the hydrogen bonds in the protein side chain. It replaces them with new bonds, changing the 3D structure and causing unfolding. Other factors, like heavy metals, can also cause protein denaturation. These disrupt the protein structure in different harmful ways. Heavy metals display essential ions in the metal of proteins or bind with protein side chains. This changes the natural structure, making it lose its biological activity, and it can be dangerous to health.
Mining and industrial waste release heavy metals into bodies of water. Fish absorb these materials, which denature their proteins and harm their function.
When people eat contaminated fish, they ingest heavy metals. This can lead to toxic effects like nerve damage, kidney disease, cancer, and many other illnesses. We should also keep in mind that protein denaturation has many benefits. For example, in cooking, it makes proteins more digestible and improves flavor and texture. It also ensures food safety by denaturating proteins and harmful microorganisms, helping to kill pathogens. In medicine, denaturation is even applied in pharmaceuticals to deactivate harmful proteins or allergens.
On the other hand, excessive denaturation of food can lead to a loss of nutritional value, making proteins less effective.
It also causes a loss of function. Denaturation destroys a protein's 3D structure, making enzymes or hormones unavailable to perform its role. Therefore, protein denaturation can be beneficial in controlled situations, but uncontrolled factors like heavy metals pose serious health risks.
Given these disadvantages of protein denaturation, it becomes clear that this issue is not only a scientific concern but also a global one. This is where Sustainable Development Goals (SDG) come in. Our study directly connects to these goals. Specifically, it relates to
Good health and well-being. The release of heavy metals by industries can lead to protein denaturation, which poses serious health risks to humans because heavy metals fluid contamination might disrupt the biological process in our body, which can cause diseases.
SDG number 6. Clean water sanitation. The release of heavy metals such as mercury, lead, cadmium, arsenic, chromium, and nickel released by industries usually reach aquatic environments.
SDG 11. Sustainable cities and communities minimizing the release of harmful chemicals contribute to a safer and healthier community to life within the industry scope. SDG 12. Responsible consumption and production. Reducing the use of hazardous waste, and it protects both the people of the ecosystem. Promoting this enables industries to adopt cleaner and more sustainable production practices.
SDG 14. Life below water. The leaching of harmful chemicals such as lead, mercury, and such which contaminates bodies of water pose a risk to aquatic life.
Tastes better. Now I know the science.
So how's school?
It's kind of difficult.
Really?